when you did the confidence intervals and you made an interval based on your sample, you kind of set it up so that your population would fall here. You're kind of doing a little bit of reverse. You're giving the population information, and you're going to test your sample against this population. And you're going to say, is that a good claim or not? Now, a lot of this is in the logic of it. I'm gonna let you use the charts and help you out there, but a lot of it is in the logic. If one part is true, then the other cannot be true. For instance, you do an experiment in science, right? So you want to test that you put a solution and you want to see at what temperature the solution dissolves. At what point it dissolves from your liquid or evaporates or whatever. And your hypothesis is, well, you think it's going to happen at the boiling point, at 100 degrees Celsius. You think it's going to happen at 100 degrees, that it should boil and your minerals should evaporate out of there or whatever. That's your claim, that I'm going to do this, that's my hypothesis. And that at 100 degrees, it's going to evaporate. Now, when you actually do this, you test your sample and you say, wow, I have to get it up to 120 degrees before my minerals are actually evaporating out of my water. My water will boil, but my minerals won't evaporate. And you do this again, and maybe you have a few different tests. You conclude that your hypothesis was not a good hypothesis. I don't know if you called it an alternate hypothesis. Did you ever call anything an alternate hypothesis? No? That it's not going to boil at that time, at that degrees? So you test this against your population. You use your sample to test against your population. And you can prove this, whether it's, you don't really say true or false. You kind of say, I can support this, I can reject this, I don't have enough evidence to reject. You're going to see there's a whole table on how you do this. So in the very beginning, we're just going to talk about the process of hypothesis testing. So a hypothesis test is a process that uses your sample statistics that you gather to test a claim about a population parameter. Again, remember, we're here. Population, sample. Population mean, sample mean. Population variance, sample variance. Standard deviation, standard deviation, sample standard deviation. Proportion, p hat for your sample. Same letters we're going to use to represent this. Because we're given information about our population, we're going to test our sample against that and see if we agree with their statement. You know, you hear, it used to be a very popular one, 4 out of 5 dentists prefer Crest. Or remember the test with they get Pepsi, like the Pepsi challenge question, you know. Yes, which one tastes better, and people come up and they drink it, and it's like A or B. Like 95% of them say Pepsi. I think there's one person that will say Coke, or I don't like Coke at all, or something like silly. But you can actually test those. You can do your sampling. We'll get a good stratified sample, a systematic sample, and you test and see if you agree with their sampling. Now, if they're challenged, they also have to present how they did all this work. So remember, they cannot make a false statement anywhere. They have to back it up somehow. So let's take a look at what this is asking. You're going to have a hypothesis statement, and I call this the null hypothesis. Did you call it a null in science? No, when you make a hypothesis, did you just say hypothesis? Okay. We're going to call, one of them is going to be a null, H sub 0, HO, called a null, and the other one is going to be called an alternative. And that's going to be called HA. Now, some books use H1, H2. I could see your phone right through the calculator thing. I would not imagine you were pressing buttons on a calculator jacket. So, put your phone away. It doesn't even have the calculator in its head, it has the jacket in its head. Put your phone away.
I thought I was slick for this.
I thought you were so slick too, but I couldn't help myself from saying it.
Not gonna lie.
Yes. Okay. Some books call this H1 and H2. It depends, it depends what they want to call it. It's still a hypothesis and an alternative hypothesis. Your alternative hypothesis is the opposite of what your hypothesis says. So if you say that this water is going to boil at exactly 100 degrees, your alternative statement says this water is not going to boil at 100 Celsius degrees. Okay, so that's what we're looking at. Now, you want to test it clean. Again, I gave you a lot of the note page for this so that we don't have to worry about taking notes. But if you just take a look at page 332, I just want you to read this with me because this really is like the whole thing about hypothesis testing. A hypothesis test on page 332 is a process that uses your sample statistics to test the claim about your population parameter, which is what we put up here. Here's another good example. For instance, suppose the cellular phone company advertises that the mean talk time of their new cell battery is 180 minutes. You suspect that the mean talk time is not 180 minutes. That's 3 hours. You're not getting 3 hours out of your phone battery. So how could you prove this false? How could you challenge this? Obviously, you can't test all the batteries from cell phones, but you can still make a reasonable decision about the mean talk time by taking a random sample from the population of batteries and measuring the talk time of each one. Now, if the sample mean differs from the advertisement mean, you can decide that the advertisement is wrong. They stated a false claim. You can challenge it. Your sample is very critical. You can't just go to your friends. You've got to sample different people that, maybe your friends are always on their phones like you are. You've got to sample different people that use their phone at different times. Don't sample their names. You'll never get 3 hours. So, for instance, to test the mean talk time of a cellular phone battery, your mean from your population is 180 minutes. You took a sample of 100 batteries and you measured the talk time. Then you take the mean of that sample and suppose it's 174 minutes with a standard deviation of 20. So you have to decide. You do something unusual. This is important, guys. You assume that the advertisement is correct. That's the only information we're given. So we assume that it's correct. Therefore, you assume that the population is equal to 180 minutes. Then you examine your sample from your 100 that you took, and you test your claim. From your center limit theorem, you know that you have to take your standard deviation divided by the square root of how many were in your sample. So that cuts your standard deviation down to 2. In the graph to the right, notice that your sample mean of 174 minutes is highly unlikely. It is a 3 standard error from the claimed mean. And using the techniques you studied, you can determine that the advertisement of obtaining a sample mean of 174 or less is very, very rare, very small. Your assumption that the company's advertisement is correct has led you to an improbable result. So you either had a very unusual sample, or the advertisement that they stated was false. You can't be that different. So you would actually have to run your samples again before you challenge anybody else. You'd have to do quite a few of them. The logical conclusion is that the advertisement is probably false. Now, probably doesn't really cut it in the business world, so you have to then resample, test, and figure everything out from there. Now, a verbal statement or claim about a population parameter is called a statistical hypothesis. So if you take a look at page 333, we have a null hypothesis. Oh, I had this up here right. And we have a alternative hypothesis. A null and an alternative. Now, in your null and your alternative, again, it could be set up as an H1, as an H2. Your book uses H sub O, which is pronounced no. and H sub A, which is your alternate. Some books use H1, H2. Depends on how they set it up. Now here's the important part. Your null hypothesis contains an equal sign. A greater than or equal to, a less than or equal to, or an equal to. Now, remember when we did your interval, we said it's very hard to get that 1 point? Well, the same thing happens when you use an equal sign, when you say it is 180 minutes. It's very hard to hit just that one. So most of the time you're going to see less than, greater than, and sometimes they use the is. And if you off a certain amount, you can still disprove it or prove it. Now your alternate hypothesis is the complement of your null. Is everything that your null is not. So if you say it is equal to 180 minutes, your alternate is it is not equal to 180 minutes. This is the most important thing though. Your null has to contain the equal sign. And your claim does not have to be your null statement. This is a lot I'm throwing at you, and as we work this through, you're going to see as we take these things apart. Your claim is whatever it says. It could say that my minutes are less than 180. My null would be greater than or equal to, and in which case that's not the claim. So be aware that they're just opposite statements. And those are the things we're just going to spend a little bit of time up front looking at. I want to get these claims down pat, because what happens is if you don't, you have a very hard time when we set the claims up. To translate your claim about the population parameter, we translate it into a mathematical statement. The mean talk time is 180 minutes. We say mean equals 180. And then we write its complement. So, for instance, this is mean talk time is 180 minutes. U is equal to 180. This is U is not equal to 180. This guy would say the mean talk time is 180 minutes or more. Or more. This is U is greater than or equal to 180. Now, think of a number line. If something is greater than or equal to 180, and I need to use the rest of this number line as its complement, I'm down here. I can't use that one. I'm this, less than. Do you see that? Okay. And if I say this, my mean talk time is 180 minutes or more. I write that statement as the mean greater than or equal to 180 minutes. Good so far? The complement of that is everything this isn't. So it has to be less than 180. I got to get the rest of this number line. I can't use that point because it was already used. So there's my less than. Do you see it? That would be your alternative hypothesis. This guy says my mean talk time is at most 180 minutes. At most says less than or equal to. So now picture your number line. It can't be more than that. That's the most it could be. So your alternative says I need the rest of this number line, this guy, but I can't use this because it was already used. So my alternative is that my mean is greater than 180. Everybody see where those are coming from? So if I give you this statement that my mean talk time, I'm going to change this, is more than 180 minutes, how would I write that? My mean talk time is more than 180 minutes. Good. U is greater than 180. Would this be my null or my alternative?
No.
The null contains the equal sign. This is your alternative. Now, your null would be what? What's the complement of this? less than or equal to. It's got to be if one's greater than, the other one's less than. If one's equal to, the other one's not equal to. The no always contains the equal sign. See the no? It always has an equal sign. The alternatives have no equal signs. Okay? Try one more. The mean talk time is less than 180 minutes. How do I write that? Less than. Is this the no or the alternative? Good. And then what's the no? Greater than or equal to. Which one was the claim? What was their statement? The claim. This is the claim. The first guy. That's the claim. That's what they said that it was going to be. So the claim does not have to be the null statement. Okay? The claim is whatever is being said or challenged or anything else from there. Now, just to get you guys looking at alternatives, here's a good statement, and I think I put this on your note page. Did I? Yeah. Just some keywords that you see associated with this. When it says greater than or equal to, there's a greater than or equal to. At least, greater than or equal to. Not less than, greater than or equal to. These are all for your HOs. So these are statements that you're going to see, meaning that's the guy that has the equal sign in it. At most, less than or equal to. Less than or equal to, and sometimes they say not more than. Most of them you're going to see the at most, at least, more than, less than, equal to. Those are the popular ones. Equal to, exactly, just some statements that they'll say. These guys are the HAs. They're the opposites, the complements. Okay? So just so that you get this down pat, because this is really important, once we find the claim, we have to set up a null and an alternative. That's our first goal every time. A lot of this in the beginning is just getting used to how to set everything up. And if you've done this in science, it's very, very similar. If you've run a science experiment, it runs pretty much the same way. You create your null hypothesis, and you test it. Okay, so let's see if we can come up with a null hypothesis and an alternative. Now, these guys are the claims. This is what they're claiming. A university publicizes that the proportion, how do I represent the population proportion? Lizzie? How do I represent the population proportion? P. P hat's my sample. Population proportion is P. So a university publicizes that the proportion of its students who graduate in 4 years is 82%. How do I write that statement? As a mathematical statement. P, what is equals 82%, 0.82. Is this the null or the alternative? No. No, because it has an equal sign. So I go like this. So therefore, what's its complement? He is not equal to 82%. That's all we have to do. Make a statement about the claim. See if it contains an equal sign, it's a null. If it doesn't contain an equal sign, it's an alternative. Okay? A water faucet, but you do have to watch what it is you're testing. A water faucet manufacturer announces that the mean flow rate of a certain faucet is less than 2.5 gallons per minute. What letter, what symbol stands for mean? U. This is from our population, right? We're using our population. So how do I write the statement that the mean flow rate is less than 2.5 gallons per minute?
U is less than 2.5.
Good. Is that the HO or the HA? HA. Good. Because this does not contain an equal sign. This is a claim. Now, look at the first one. The claim contained the equal sign. This is the second one. It doesn't contain the equal sign. That's okay. The claim can be anything they state. So what's the HO for this guy? What's the complement of this?
U is
Greater than or equal to. If you struggle with this, use a number line. Here's 2.5. It's open and it's this way. The complement has to be everything else. It has to go this way, and since it was not open before, it was open, now I have to close it. So this guy has the equal sign in it. Okay? Let's try one more. A cereal company advertises that the mean weight, again, the symbol we use is the mu, of the contents of its 20-ounce size box cereal is more than 20 ounces. How do I write this? U is greater than 20. Is this the HO or the HA? HA. How do I write the null? Good. Everybody good with this? All right, before you pack it up, try it yourself, number 1. On the bottom of 334. It's only going to take you a minute to do this. Whoops. On the bottom of page 334, try it yourself, number 1. Okay, you work on this, and tomorrow when we begin, I want to see that